Okay, in this video, we are going to use this example in order to find out all the things we need to know about the exponential function. Okay. In the example that you see in the screen, this is a sketch that is given by f of x equals a to the power of x. So this is the standard version of the exponential function. Okay, where I want us to start, what I want us to do now is put a Cartesian plane here. Okay, I'm going to grow it a bit. Now, things that are important. The function has an asymptote. Okay, so asymptote, remember, is a point on the graph whereby the function will never reach that point, right? Remember the asymptote as in the parabola, the hyperbolic, sorry. It's points on the graph whereby those points are undefined. Now, remember we have f of x equals a to the power of x. Now, which square root can give you a zero y value? There isn't. That would mean that the x values, a graph will never cut on the x-axis. It'll come close, but it will never ever reach the x-axis. Now, remember, this graph is going like this. Right? It's coming from a very high y values, right? And then it is coming down into the positives of the x values. And it's coming very close to the x-intercept, but we know that there's no value that will give us a point where y is 0. This means that when you see the graph going like this, the graph is decreasing. Right? Because we know that a will be greater than 0, but a will also be less than 1. You see that? So this means that this graph is decreasing. But if the graph was doing this, the graph now will be moving away from the x-intercept, right? And moving further and further and further and further away, right? If this was the case, the graph would be increasing. Correct? This means that A would be less than 0 but greater than 1. Okay? But that's really pretty much what you need to know. Those are the type of questions that will ask you, and then they are going to ask you to solve the equation of the function, which is what I want us to do now. So let's go to the question. Let's go there. Okay, we're going to write down the coordinates of point A. So point A cuts on the y-axis. That means at that point x is 0. So we have the value of 1 of x, right? So come here, we say question 2.1, we say if f of x is equal to a to the power of x, f of x when a is 0, anything to the power of 0 is 1. So we know that a is 0 and 1. Fair enough. I think that's pretty straightforward. Yeah. Now, how can we tell that a is greater than 0 but less than 1? We tell it because the graph is decreasing, right? That will be our answer. We can write here the graph is decreasing. Okay, we continue. Now, determine if B is the point 3 and 1 over 27. Okay, so now at this point we would need to find all the values of f of x equals a to the power of x. Okay, so now we have question 2.3 saying that 3 and 1 over 27 is a point on this graph. So f of x is equal to a to the power of x. Okay, we know that 1 over 27 is equal to a to the power of 3, right? That means a is equal to the root of 3. A is 1 over 3. Okay? Okay, just need some room there. Okay, now we know what f of x is. So we know that f of x is equal to 1 over 3 to the power of x. We're going to test this. Then we're going to say if y is 1 over 27 equals 1 over 3 power of x, then x is equals to log 1 over 3, 1 over 27. You type that into your calculator, you find that the value is 3. It's the exponential value. Remember, you can do this when working with exponents. Okay. Determine the equation of the graph obtained by f if it's reflected about the y-axis. Okay. So now, if the graph is reflected on the y-axis, that means now we would need to get a ascending graph. Remember, this one was going down. Now we need to get it to go up, right? So we need we need the inverse of this graph. Okay. So now what I'm going to do to get some space here, I'm going to erase all of this. So that we don't get confused. Okay. We're going to say f of x is equals to 1 over 3 power of x. Right? Now, the inverse on this is going to be negative x values, right? So I'm going to say f of x, I'm going to call it f of x minus 1 is 1 over 3 minus x. But remember that this can also be written as 3 to the power of minus 1. Right? And if I multiply those two exponents, I get 3 to the power of x. So that's the inverse function, whereby now this graph has been reflected on the y-axis. Happy? What is the coordinate of the points of intersection of the two graphs? Okay. So remember, it's reflected on the y-axis. That means they will share a point there on that y-axis. So that means the point of intersection is again 0 and 1. Right? Because anything to the power of 0 is 1. So when x is 0, y is 1. And we have a point of 0 and 1 on the inverse function.